Hello everyone, myself Prajwal. I have done Masters in Chemistry at Indian Institute of Technology, Madras. In this session, I am going to discuss about ionization energy. Let us see what is ionization energy, the definition of ionization energy. The minimum amount of energy required to remove the most loosely bonded electrons from the isolated gaseous neutral atom. So, to understand this, I will take an example. I will draw a shell. So, it has three shells. So, we call it as the element will belong to third shell. I hope everyone know about shells and the maximum electrons can be filled in each shell. I'm not going to discuss about that. So to illustrate this, to take an example, so I have taken two shells. Like I'll fill the electrons first. So this is the nucleus, and first shell the maximum will be 2 electrons, and in second shell the maximum will be 8 electrons. I'll fill maximum electrons. 3, 4, 5, 6, 7, 8, and in third shell the maximum electron will be 18. So for our understanding, I'll take 4 electrons. In this, I'll take let it be 7 electrons, and this is 2 electrons. So what it's basically saying, the definition is saying the amount of energy required to remove the most loosely bonded electron from the isolated gaseous neutral atom. So by seeing this first shell and second shell, we cannot say that, like, we cannot predict which is loosely bonded electron. So we like, without knowing any concept, so we can't say that which is loosely bonded electron. How can we you can ask, how can we predict, how can we know this electron is loosely bonded? Because all the electrons are filled the same in same form. The only thing is, what you should remember is, when we remove an electron which is farther from the nucleus, listen it properly, when we remove an electron which is farther from the nucleus, we require less ionization energy. I'll take an example. Let the radius will be 20. From this nucleus to outermost shell, the radius is 20. Here the radius is 16. So to remove an electron from here, we required ionization energy. We required plus 420 kilojoule per mole. So just for understanding, to remove an electron from here, from the second shell, we required ionization energy. I'm talking about first ionization energy. Required 600 kilojoules per mole. The energy, I'm talking about energy, right? So I'm using kilojoule per mole. So you may think, why it's happening, why we need more, why we need less ionization energy, why we need more ionization energy to remove an electron from second shell. The only thing is, what you should remember is, so we know the concept, we have been studying from 10th or 8th standard, 9th standard. Like poles repel each other and unlike poles attract each other. The simple concept, like pole will repel each other and unlike pole attract each other. And we also know that nucleus is positively charged and electron is negatively charged. So when electron is nearer to the nucleus, so listen properly, when electrons is nearer to the nucleus, it will attract, action will be more. So to remove an electron from that particular shell, we required more ionization energy. So in this second shell, you can see nucleus and second shell, nucleus and second shell is nearer. That is, I have given radius is 16. For rough understanding, I have given radius is equal to 16. But here I have given radius is equal to 20. So the third shell is somewhat farther than compared to second shell. Or you can take here itself, right? It's easy. R is equal to 16. So if you want to remove an electron from here, you require more ionization energy. Ionization energy is 600 kilojoule per mole. But to remove an electron from third shell, you require less ionization energy. Because only thing is, the third shell is somewhat farther than compared to second shell. So to remove an electron from the second shell, you require more ionization energy. This is the concept. So this is the concept you should remember. What is happening in ionization energy and what is ionization energy mean? The minimum amount of energy required to remove the most loosely bonded electrons from the isolated gaseous neutral atom. So I'm talking about neutral atom. That means there's no positive or negative charge or nothing. It's just a neutral atom. So let us take an example to know about complete picture of this concept. I'll take an example of sodium. So and also you should know this is affecting on that particular concept, like on the particular ionization energy, there are some concept which is going to affect. So I think in this demo class I'll only discuss about ionization energy. So it's better to know complete concept, the factors and also what factors is affecting on the ionization energy and the definition. So it might ask these questions is been asked in Kcet exams and also board exams also. So let me take an example. Sodium. What's the sodium electronic configuration? 1s2, 2s2, 2p6, 3s1, because atomic number is 11. And I'll draw shells. I'll draw a shell. Let me fill an electron first. 1, 2. And again I'll take another example. Okay, I think let me explain from this. I'll introduce a new concept. I mean, it's not. It's not a new concept. That the concept again that comes under factors affecting. So let me explain that. In this particular example, I have an ionization energy. I require ionization energy to remove an electron which is present in third shell. So to remove an electron from the third shell, as I said, is far from nucleus. So we require less ionization energy. I'll take ionization energy 1. To remove an electron from the outermost shell, we require less ionization energy. So if we put next energy, like second ionization energy, what is going to happen? So to remove an electron from second shell, that's called second ionization energy. Because in third shell there is only one electron which is taken away, which is removed. So to undergo second ionization energy, to remove an electron, that is second electron, we have to pick an electron from second shell, right? Because in third shell there is no other electron, there is no another electron. So one electron was there and we already removed it. For second shell we have to remove an electron. Do you think we required more energy than compared to first ionization energy, than compared to removing a electron from third shell? Obviously yes. Answer is yes, because it is nearer. Second shell is nearer than compared to third shell. That is one concept. Okay, that is one concept, that it required more ionization energy. That is second ionization energy. So in this second, to undergo this process, second ionization energy required more than compared to first ionization energy. And also you should remember another concept, that is half filled and completely filled are more stable. So I'll show an example. I'll show you an example here. 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. To remove an electron, see, once you remove an electron from third shell, it will become like this. Because in third shell there was only one electron. So we removed an electron from a third shell. We call it as sodium plus. So as positive charge increases, the atom size decreases. That's one concept. I think you all know. as positive charge increases on the atom, the size of that particular atom decreases. That's one concept. Another concept you have to remember in this particular example is, when you remove an electron which is completely filled or half filled. What I'm seeing in the 2p, I have taken a 2p orbital. If you take 2p orbital, in p, like in p orbital there are 3 orbits. In these 3 orbits, the maximum electrons can be filled is 6, right? Or we can fill 3 electrons which is half filled. So you should remember that half filled and complete filled are more stable than compared to any other. So if it is like this, 1 2 3 4 5 6, so 4 5, so 5 electrons are there. When you compare these two, you require more ionization energy to remove an electron from here, because it is exceptionally stable. Half filled and complete filled are exceptionally stable. And also, if you want to remove an electron from here, you require more energy than compared to here. So even though it has 5 electrons, but that doesn't matter when you have half filled and completely filled. So you should remember half filled and completely filled are more stable. As I said, we require more ionization energy. One thing is, it is nearer, that is positive and negative will attract each other. And also one thing you should remember that you may think, why can't it give an electron? Why can't we can remove an electron easily from third shell or second shell? Only thing you should remember is, we know the concept that positive and negative charge will attract each other. The attraction will be more when the positive and negative charge is present. So you know, positive charge is like nucleus is positively charged and electrons are negatively charged. When nucleus that is positively charged and electrons are nearer, which is like very near, the nucleus when the electrons and nucleus are very nearer, to remove an electron, that particular electron, you require more ionization energy. So you can notice here, the second shell is nearer to the nucleus than compared to third shell, right? Than compared to third shell. Let me radius be 20 and this radius is 6. This second shell is nearer. To remove an electron from me, you get more ionization energy. Again, the concept you should remember, we are going to remove an electron from 2p orbital, right? We are going to remove an electron from 2p orbital. So 2p orbital electron we are going to remove. As I said, half filled and completely filled are more stable. In 2p orbital there are 6 electrons. There are 6 electrons. To remove an electron from completely filled, we require more ionization energy. So in this particular example, second ionization energy is more than compared to first ionization energy. Okay, I hope you understood the concept. In coming video, I will discuss about the factors affecting. Okay, thank you.